Welcome, class. Today, we're going to bridge the gap between abstract mathematical theory and the very concrete, high-stakes world of business finance. We're here to learn the language of financial decisions, and it's a language built not on words, but on precise calculations that can literally make or break a company. My goal today is to give you the foundational tools to analyze and compare investment opportunities, a skill that's going to be absolutely invaluable for the rest of your careers. So let's just dive right in with a scenario you'll definitely face out there in the real world. Take a look. You've got two choices for your $50,000. Option A is a new project. It promises you 75 grand in 5 years. You know, on the surface, that looks like a pretty sweet $25,000 profit. Then there's option B, a much safer, predictable savings account, giving you 5% a year. The real puzzle here isn't just about the numbers themselves, it's about the timing. How on earth do we compare $75,000 5 years from now with $50,000 in your pocket today? This is the central question of finance, and it gets us right to the core idea of the time value of money. Now, to even begin to answer that question properly, we have to first get a real grip on what is, without a doubt, the most powerful force in all of finance. It's a concept that Albert Einstein supposedly called the eighth wonder of the world, compound interest. Think of it as the engine that drives all financial growth. Understanding this isn't just about passing a test. It's about understanding the fundamental mechanics of how wealth is actually created.
Okay, let's really look at this definition. This isn't just some static event. It's a dynamic, accelerating process. You see, simple interest is linear. It's predictable. You earn the same amount period after period. But compounding is exponential. Your money earns interest. Then that interest gets added back into the pot, and the next time around you earn interest on that new, bigger amount. It's a snowball effect that starts small, but given enough time, turns into an absolute avalanche of value. That right there is the magic of compounding.
So how do we capture this powerful idea? Well, it's all wrapped up in one fundamental formula. Our job today isn't just to memorize it. No, we're going to deconstruct it, really understand its architecture, and see how it works as a powerful tool for making strategic decisions. This formula is literally the key that unlocks the power of compounding. All right, I know what you're thinking when you see this. A jumble of letters and parentheses, it can look a little intimidating, but I want you to see each of those variables as a lever that you as a business leader can pull to change a financial outcome. A is just the amount you'll have in the future, P is what you start with, R is your interest rate, N is how often that interest gets calculated, and T is time. Every single one of these pieces plays a critical role in the final result. Let's really dig into these. P, the principal. That's your starting capital, right? Your initial bet. R, the rate, is basically the price of time. It's what you get paid for waiting or what you have to pay for borrowing. Now, T, time. Time is your most powerful ally here. It's the runway that lets that compounding snowball really pick up speed. And then there's N, the number of compounding periods. N is kind of the secret accelerator. Let me show you exactly what I mean. Now look closely at this chart. The only, and I mean only, thing that's different between these two columns is N. In one case, we calculate interest once a year. In the other, 12 times a year. Just by doing that, we end up with an extra $181. Now, you might be thinking, so what, it's not that much. But you have to scale this up in your mind. Imagine this overall 40-year career, with way more money, at a higher rate. The difference becomes absolutely astronomical. This is why understanding these mechanics is so crucial. Small, consistent changes lead to massive results over time. Excellent. So now that we understand the compounding engine, we can build our two most important analytical tools. These are the tools that let us compare money across time, future value and present value. And as you can see, they're really just two sides of the exact same coin, and you'll need both of them to make smart financial decisions. So future value, or FV, is like a financial time machine that only goes forward. It helps us answer that really basic planning question. If I invest this chunk of money today and it grows at this rate, what will it be worth at some point in the future? This is what you use for retirement planning or for a company trying to figure out if it can afford a big expansion down the road. It's all about seeing where your decisions today will take you tomorrow. Present value, or PV, does the complete opposite, and for making business decisions today, it is arguably the more powerful concept of the two. PV yanks the future back to the present. It answers the question, that promise of a big payout way down the road, what is it really worth to me, right here, right now? This process is called discounting, and it is the absolute bedrock of modern finance.
It lets us put a real, today-in-your-hand value on any future amount of cash so we can finally compare different opportunities apples to apples.
And just like that, we've come full circle. We are now officially equipped with the analytical tools we need to solve that opening problem we started with. And we're not going to use a gut feeling or a guess. We're going to use mathematical certainty. Let's apply what we've just learned. Okay, here's the setup again. We have our two options. And remember, we absolutely cannot just subtract 50 grand from 75 grand and call it a $25,000 profit. Why not? Because that would completely ignore the time value of money. It ignores the opportunity cost of having our money tied up for 5 long years. To make a logical, rational decision, we have to find a common ground. And the way we do that is by bringing everything back to its value today, its present value. So let's tackle option A first. We take that promised $75,000 from the future and we discount it or pull it back to today. We'll use the 5% rate from the savings account as our baseline, our discount rate. The formula, as you can see, is PV equals FV divided by 1 plus R to the power of T. We plug in our numbers and what do we get? We find out that a promise of $75,000 in 5 years is the same as having $58,835 in your hand today. That is its present value. Now, just so we can see the whole picture, let's quickly look at the future value of option B. If we just played it safe and put our $50,000 in the bank, it would grow to about $63,814 in 5 years. Now, notice that's less than the project's promise of $75,000. So you might be tempted to think, oh, option A is better. But hold on. That's a future-to-future comparison, which isn't the most accurate way to decide. The real decision, the most powerful analysis, happens in the present. That's why present value is our key tool here.
So, this is the crucial moment. Here's the bottom line. The project costs us $50,000 today, but the present value of what we get back is $58,835. Since the value we receive, measured in today's dollars, is greater than the cost we pay today, the project actually creates value. It has what we call a positive net present value, or NPV, of $8,835. The math here is crystal clear. The project is the better financial choice. It literally increases our wealth in today's terms.
Okay, so getting the right answer is obviously critical, but in my experience, the biggest reason students and frankly professionals get these problems wrong isn't because they don't understand the big concepts. It's because of a simple, totally avoidable error in how they set up the problem. And in the business world, these tiny errors can have massive multi-million-dollar consequences. Let's talk about the common traps. Let's walk through these because they are so important. The number one error I see, hands down, is mismatching units. If your interest rate R is an annual rate, your time T has to be in years. If you use an annual rate but plug in the number of months for T, your answer will be wildly incorrect. The next one is just forgetting about N when interest is compounded more than once a year. That will always make you underestimate how much money you'll have. And finally, before you even pick up a calculator, just pause for 1 second and ask yourself, what question am I trying to answer here? Am I trying to see into the future, or am I trying to value something today? Just asking that simple question can save you from a world of hurt. So let's just zoom out for our conclusion. Let's pull back from the formulas and look at the big picture. What you've been learning today isn't just a chapter in a math book. You have been learning to speak the fundamental language of business, and that is the language of value. This is the language that lets you communicate effectively and persuasively with everyone you'll work with. So why does this matter for your career, even if you're not going into finance? Because every single important business initiative, from a new ad campaign to building a factory, is an investment. A marketing manager uses these ideas to justify their budget. An operations manager uses them to decide if it's worth buying a new piece of equipment. A CEO uses them to decide which companies to buy. You simply cannot be a leader in any field without being fluent in this language. And this brings us to the final and maybe the most important thought I want to leave you with. The formulas, they are perfect. They are pure logic. They will never mislead you. The real world, on the other hand, is messy. The biggest challenge you will face in your career is not in doing the math correctly. It's in figuring out what numbers to plug into the formula. What's the right discount rate? How sure are you about those future sales projections? The math will give you a precise answer based on your assumptions. Your job as a future business leader is to develop the wisdom and the critical judgment to make sure those assumptions are sound in the first place. That is the true art that goes along with this science. Remember to always question your assumptions.